Okay, so we are going to be going over the answers for the 122 day 1 homework, which was numbers 84 through 91. So first thing we're going to do is start with number 84, and it says use any method to find the points of intersection of f of x equals 2x squared minus 3x plus 4 and g of x equals x squared plus 5x minus 3. So it says using any method. I can show you the method algebraically, and then we can go over it on the computer, so or on the calculator. So when you're doing it algebraically, which is from the math notes box, you set these two equations equal to each other, because if you're looking for the intersection, you're looking for where those two equations meet, which is where they are equal to each other. So you can set this up, set them equal to each other, and then move all of your variables over to, or all of your terms over to one side and set it equal to 0. So I'm going to subtract my x squared, subtract my 5x, and add my 3. So that all three of these are now gone on the right-hand side. And I now have x squared minus 8x plus 7 equals 0. So now we have a quadratic, which we can factor this. So when you're trying to factor this, you figure out, because this is a 1 in front, you can figure out what multiplies to get to 7, but those same two numbers, when you add or subtract them, should give you negative 8. So the only way to multiply to get a 7 is 7 and 1, so this one only had a few options. So then the way to get a 7 and a 1 when adding or subtracting to get to negative 8 is a negative 7 subtract 1. So then now you use the zero product property and set them each equal to 0 and solve them. So add 7 to both sides to get positive 7 and add 1 to both sides to get positive 1. So now what we just figured out was the x coordinates for those intersections. So what I'm going to do is plug in each of these and figure out what their y coordinates are. So I'm going to do f of 7 first. It doesn't matter if you plug it into f or g, doesn't matter. So I'm just plugging it in the first one. And then I'm going to type all that in my calculator, and I figure out that when I input a 7 into the x, I get an 81 as the output. So that means that coordinate is 781. So that is one intersection. Now I'm going to do the same thing for the other x coordinate. So I'm going to do f of 1. And again, I just picked one of the functions and I'm plugging the answers into it. And then I'm just going to type that in my calculator or do the math in my head, and I figure out that when I plug 1 into the function, I get 3. So that means this intersection is 1, 3. Input, output, x, y. So here's your two intersections. So then when you if you wanted to graph this in Desmos or in the graphing calculator, you can do the exact same thing. It's just a little bit harder because sometimes the numbers are a little bit bigger. So we have 2, remember this is your x key, so 2x squared, I can't read the equations, minus 3x plus 4. And then your other equation is x squared plus 5x minus 3. And then hit graph. There's my blue one. And there's my red one. But now remember that we can't see where they're crisscrossing in the picture. So then you can go to the table and figure out where do their y coordinates match, which is where are they equal. So when I popped up, I got one perfectly. So there's 1, 3, which is one of the ones that we came up with mathematically. So when you looked at the table, so I'll just draw a quick table here. So I saw, I'm not going to write them all because there's a ton. So I showed there's 1, 3 on there. And then the other one we know algebraically is at 7. So I'm just going to kind of keep scrolling. And then if you keep scrolling and you look, there's 7. And then the 81s match. So 7 and 81 on both of them. So again, trying to figure out where they intersect on the screen. And you could have zoomed out and you could have scooched over and moved your window up. So if I move my window up, what do we say it was? 81? Jeez. high enough, I would have been able to see where that crisscross is. But look, when you play with the window too much, it kind of gets a little messy. So I personally like to use the table or the equation and then use one of the other ones to check it. So we got two ways to get the same answer. This one's a little bit quicker, but sometimes you got to fiddle with this one a little bit. So just be careful with doing it in the calculator. Okay, so then that was it for 84. So in 85, says to solve the equation for x. So we get negative 2 parentheses x plus 4 equals 35 minus, in parentheses, 7 minus 4x. So this was very similar to the one from the quiz last week. So distribute the negative 2 through with multiplication. And now you have to be careful. This 35 is not attached to the parentheses. That's technically a minus 1. There's an imaginary 1 right there. So that's what you're distributing through. So now it's negative 7 plus 4x. So then now you can combine like terms and move everything from one side to the other. So we have negative 2x minus 8. And then you can do 35 minus 7. And now add 8 to both sides and subtract your 4x over. And then you're going to divide both sides by negative 6. And there's your answer. So then that was part A. Part B is a little bit different. It's set up as a proportion, which if you remember from Algebra 1 is two fractions set equal to each other. So when you have two fractions set equal to each other, you can cross multiply them. And be careful when you cross multiply them, you are really just making a big distributing problem. So you have 5 times all of that. So it's 5 times x minus 4. And then 7 times all of this means 7 times, and you keep everything together with parentheses. Now, just like the last one, distribute. So 5 times x and 5 times negative 4. And then 7 times 8 and 7 times negative 3. So now I'm going to move my 20 over by adding it to both sides. Add my 21x to both sides. And then divide both sides by 26. Now you have two options here. If you want to leave it as 76 over 26, then you can have an equal sign. If you're going to type that into the calculator and round, remember you need the approximate symbol, which is like a wavy equal sign. And if you want to round, that's fine. That's 2.92. And we don't care how you round. But just make sure you have the squiggly equal sign for that guy. Okay, so now the next one is number 86. So it says make a complete graph of the function square root of x minus 2, label its y-intercepts and x-intercepts, and describe its domain and range. So for this one, I'm actually going to use graph paper because it says make a complete graph. So when you make a complete graph, that's when you need all of those different components. So for 86, it says f of x equals square root of x, and then outside the square root symbol is the minus 2. So when you go to type this in, you have to be very careful that you tell the calculator to get out of that. So I'm going to clear these guys out of here. And it says square root of x, so second square root of x. Now the blinking right arrow, to get out of there, you hit the right arrow. So now you're outside of it, and then you can click minus 2. Make sure you hit minus and not negative. So let's take a look at that guy. So it's like a little curved swooping thing starting here and going off into infinity that way. So this is going to be what I make my complete graph on. And remember, when you make the complete graph, you need to label your axes, or scale your axes, label your key points, use graph paper, and make sure that you plot everything accurately. So in order to plot accurately, I'm going to use my table. I just made it worse, sorry. So we have 0, 1. Or pardon me, 0, negative 2. So I'm going to go up by 1s both ways. So I'm going to write that down. So this is going negative 1 and this is going positive 1. Otherwise I can go by 2s, 5s, whatever you want. So I have 0, negative 2. And then I have 1, negative 1. And I have 2 and about a half. 3 and a little lower. And then here's my 4, 0. That's a good one. And then if you look all the way down here, I have 9, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I do have enough room. So there's another good one that I can put. So these ones are going to be a little fuzzy in the middle, but now I can draw a nice curved, like swooping motion, so I can get an accurate and complete graph there. So now for the complete ones, to label, you just have to label the x and y intercepts for this guy. So I'm going to label him as 0, -2, and then label this intercept as 4, 0. Remember, the key points for now we can just do are the intercepts. So there is your x and y intercept, and it asked us for that. And then the other thing it asked us to do was to describe the domain and range. So the domain is talking about how far left and right does the graph go. So your x's, so it looks like as I'm looking this way, I have no graph on any of these points, no graph, no graph, no graph. Now I hit the graph. So I hit the graph right here when x is 0, and then it keeps going forever in the arrow. So your domain is x can be greater than or equal to 0. And then your range, now I'm going to start at the bottom and I work my way up, and then I hit a graph right there. So what is the y coordinate right there? That's -2, and it goes up and keeps going up slowly in that direction. So y has to be greater than or equal to -2. And then just to label my information from my graph, my x-intercept was 4, 0, and my y-intercept was 0, -2. So that was everything it asked for number 86. Okay. So then 87 says write and solve an equation or a system of equations, which means more than one, to help you solve the following problem. A cable 84 meters long is cut into 2 pieces, so that one piece is 18 meters longer than the other. Find the length of each cable. So when it's giving you clues, it says a cable is 84 meters cut into 2 pieces. So what that's telling me is that 2 pieces added together is going to be the 84-foot cable. And I don't know what those pieces are, so I'm adding 2 unknown pieces to make 84. It does give me a clue about one of the pieces. It says cut into 2 pieces so that one piece is 18 meters longer than the other. So one of my pieces is going to be 18 meters longer than the other. And I just have 2 unknown pieces that I gave variables to. Now you can use the substitution method. You know that x equals all of this. So algebra 1 says that we can take it and plug it into the other equation in that place. So instead of x plus y, I'm going to write 18 plus y, so all of this, and then plus y equals 84. So I substituted out the x and plugged in what we know x is equal to. That's not a number, but it's still an expression for what x represents, and you can plug that expression in. So now I'm just going to solve for y. So I have y plus y, so I actually have 18 plus 2y equals 84. Now I have one variable that I can solve for. So subtract 18 from both sides and divide both sides by 2. So one of my pieces of string, or not string, cable, is 84, it's not even feet. It's in meters. So there's your attention to precision, making sure you label for the word problem. And then it says the other piece, so we know the other piece is going to be, I'll write it higher. The other piece is 18 inches longer than the first piece. So I mean we have 18 plus 33, so the other piece is going to be 51 meters long.